500 tons. Not cargo, not the weight of what it carried. 500 tons of iron, steel, rivets, boilers, gears, chains, and cable sitting in the water, moving under its own power, tearing the edge of the continent apart one bite at a time. When this machine went to work, the coastline didn't resist. It gave way. Sand vanished, river mouths shifted, harbors deepened. Entire stretches of shore were rewritten so completely that maps became lies within a decade. People like to imagine coastlines as permanent things, immutable boundaries between land and sea. But in the late 19th and early 20th century, engineers learned something unsettling. The shoreline was soft, and with enough steam, you could move it. This wasn't a ship. Ships float and pass through water. This thing occupied it. A dredge so massive it blurred the line between vessel and factory, anchored in place by its own weight, feeding on the earth beneath it. It didn't sail anywhere. It didn't need to. The land came to it. And when it started digging, there was no stopping it. No computers. No depth sensors. No digital charts. Just pressure gauges, whistle signals, human judgment, and a machine so heavy that if anything went wrong, it didn't fail gently. It failed catastrophically. This is the story of the 500-ton dredge that reshaped entire coastlines, and the men who stood on vibrating steel decks while the ground disappeared beneath them. To understand why this machine existed at all, you have to understand the problem it was built to solve. By the 1880s, America was choking on its own success. Industry was booming. Cities were expanding outward and upward. Timber, coal, grain, steel, everything moved by water. Rivers were highways. Harbors were lifelines. If your port was shallow, your city was already dying. But nature had other plans. Rivers silt up. Storms shift sandbars. Tides move sediment with stubborn, relentless patience. A harbor that was deep enough one decade could become unusable the next. Ships grew larger, drafts grew deeper, and suddenly the same coastline that built a city was strangling it. Groundings became common. Hulls tore open on unseen bars. Cargo ships waited weeks for tides that might never come. Dynamite didn't help. Manual dredging barely made a dent. So engineers did what they always do when confronted with an immovable problem. They built something heavier. The early dredges were modest, floating scoops, bucket chains mounted on barges, steam winches pulling up mud and dumping it over the side. They worked fine for canals and rivers, but coastlines were a different animal. Open water doesn't sit still. Waves rock platforms. Tides fight anchoring lines. Sand collapses back into holes as fast as you dig them. To excavate the seafloor at scale, you needed mass, immense mass. By the turn of the century, dredges crossed a threshold. They stopped being boats with tools and became machines that happened to float. 500 tons was not an accident. It was deliberate. Weight meant stability. Stability meant precision. Precision meant you could cut into the seabed without the entire structure tearing itself apart. Picture it. A steel hull wider than most houses, riveted plate over heavy frames, designed not for speed but for immobility. Above it rose a lattice of gantries, ladders, steam lines, and hoisting towers. Boilers sat low in the hull, massive, cylindrical pressure vessels fed constantly by coal-fired furnaces. Steam pipes snaked everywhere, wrapped in insulation and leaking heat into the air. At the front, the business end, hung the ladder. A steel truss as long as a city street, angled down into the water, carrying an endless chain of steel buckets. Each bucket was big enough to crawl inside. They bit into the seabed one after another, ripping up sand, clay, gravel, shell, even soft rock, lifting it screaming toward the surface. When the dredge engaged, the ladder groaned. The buckets rattled. The entire structure vibrated with low-frequency violence you felt in your teeth. This wasn't a clean operation. It was mechanical erosion on an industrial scale. Every minute, tons of earth came up. Every hour, the coastline changed. Nothing about operating this machine was subtle. The boiler pressure sat near the red line all day. Firemen shoveled coal until their shoulders failed, then shoved some more. Steam drove everything: the bucket chain, the hoists, the swing winches, the spud poles that pinned the dredge in place like steel tent stakes driven into the seabed. Those spuds were critical. Giant vertical steel columns dropped through the hull into the bottom, locking the dredge in position. When the machine advanced, the spuds lifted, the hull crept forward inches at a time, and the spuds slammed back down again. It didn't glide. It stomped. If a spud jammed, the dredge twisted. If it twisted under load, the ladder could bend. If the ladder bent, the bucket chain could derail. And if that happened, hundreds of pounds of steel buckets came loose under tension, whipping through space with lethal enthusiasm. Men died that way. They knew it. They kept working anyway. The crew lived on the dredge for weeks at a time. This wasn't a 9-to-5 job. The machine ran as long as coal and daylight allowed, and sometimes longer. Bunks were crammed into the hull. The air smelled of steam, oil, wet metal, and burnt coal. Everything was damp. Everything rattled. Sleep came in short, stolen stretches between shifts. You learned to rest while the deck shook beneath you, while chains clattered overhead, while the bucket ladder screamed as it chewed through the bottom. Above deck, operators stood at open controls: no enclosed bridge, no climate control. Just levers, wheels, and gauges exposed to wind and spray. In winter, ice formed on the handrails. In summer, the steel burned your palms. Communication was by whistle and gesture. The noise was constant. Steam vents hissed. Gears clanged. Buckets slammed into tumblers. You didn't talk so much as shout shapes at one another and hope they were understood. Mistakes were expensive. A misjudged cut could undermine a bank and collapse tons of material onto the ladder. A snapped cable could flail across the deck like a living thing. A boiler problem didn't give you time to think, only time to run. The dredge did not forgive. And yet it worked. Harbors deepened. Channels straightened. Coastlines that had been shallow, useless barriers transformed into industrial gateways. Ships that once waited offshore now steamed directly to docks. Cities expanded outward into land that didn't exist 10 years earlier. In some places, the dredge didn't just remove material, it created it. Spoil was pumped through pipes and dumped elsewhere, building new shorelines, new peninsulas, new foundations. What had been water became land. What had been land disappeared into the sea. The dredge did care which direction progress went. It only knew how to move mass. Maps changed. Property lines shifted. Old fishermen swore the currents were wrong now. They were right. The dredge had altered them. And still the machine kept digging. But beneath the productivity was tension. Mechanical, human, geological. The deeper the dredge cut, the more unstable everything became. Soft layers gave way to harder ones. Gravel jammed buckets. Clay clogged chutes. The ladder strained under uneven loads. Boilers ran hotter. Crews pushed harder. There was always pressure to go faster. More depth. More tonnage. More hours per day. Because every idle minute meant ships waiting, money lost, contracts threatened. The dredge was expensive, immensely expensive. It had to earn its keep. So they ran it hard. Sometimes too hard. And when something finally went wrong, when iron met its limit, the results were spectacular. But before we get there, before steel bends and steam escapes and men make split-second decisions they won't survive, we need to understand the machine more deeply. Because this dredge wasn't just big. It was an ecosystem of moving parts, each one capable of killing you in a different way. By the time the dredge was fully engaged, there was no single point you could call the machine. There was only a system. 500 tons doesn't move because one thing turns. It moves because everything turns, pushes, pulls, resists, overheats, and barely holds together. The dredge worked not because it was elegant, but because every component was overbuilt to the edge of absurdity, and then driven hard anyway. At its heart were the boilers. Not one, never one. Multiple boilers sat low in the hull, their weight deliberately placed below the waterline to keep the dredge from rolling itself apart. Each boiler was a riveted steel cylinder as long as a boxcar, wrapped in lagging, sweating heat into the air. Inside, water sat inches away from fire. That distance, measured and watched obsessively, was the line between power and catastrophe. Firemen worked those boilers like men tending wild animals. Coal went in constantly. Too little and pressure sagged, starving the engines. Too much and the gauge crept upward toward a number nobody wanted to see. Steam pressure drove everything: the bucket chain, the hoists, the swing engines, the pumps, the spuds. If pressure dropped, the dredge slowed. If it spiked, it tried to kill everyone aboard. There was no automation, no fail-safe shutdown, just needle gauges, glass sight tubes, and experience. A fireman who misread the water level didn't get a warning light. He got a boiler crown overheating, metal softening, and then, if he was unlucky, an explosion that erased the center of the dredge in a heartbeat. They'd seen it happen elsewhere. Everyone had. That knowledge hung over every shift like fog. From the boilers, steam flowed outward through thick pipes to engines mounted everywhere, compact, brutal machines with exposed linkages slick with oil. These engines didn't spin fast. They pushed. Torque mattered more than speed. Every engine was geared down, built to drag enormous loads against resistance that never relented. The bucket chain was the star of the show. An endless loop of steel links ran over massive tumblers at the top and bottom of the ladder. Bolted to those links were the buckets, heavy steel mouths with reinforced lips, shaped to bite and hold. As the chain descended, the buckets plunged into the seabed at a carefully controlled angle. Too shallow and they skimmed uselessly. Too steep and they jammed, filling unevenly, overloading the chain. Operators adjusted that angle constantly using steam-powered hoists. Inches mattered. Degrees mattered. The difference between productive digging and catastrophic failure was often invisible until it was too late. Each bucket came up full: sand, mud, shell, stones, slamming into the upper tumbler and inverting with violence. The contents spilled into chutes that rattled and shook, carrying material away to barges or pipelines. The empty bucket vanished downward again, already accelerating, already hungry. The noise was constant, not loud in bursts but relentless. A mechanical roar layered with metallic clatter, steam hiss, and the deep, rhythmic thud of buckets engaging earth. It never stopped. It got inside you. Crewmen said you could still hear it days after stepping ashore, a phantom vibration behind the ears. Controlling the dredge's position was as important as cutting. The machine didn't drift, it advanced. Spud poles, thick steel columns taller than a man, dropped through sleeves in the hull and drove into the seabed. When the dredge cut forward, one spud held while another lifted. Steam winches hauled the hull ahead inches at a time. Then the lifted spud slammed back down, anchoring the dredge again. This inchworm motion was slow, deliberate, and dangerous. If a spud hit uneven ground, the hull twisted. If the hull twisted, the ladder alignment changed. If the ladder changed under load, stresses spiked through the chain and engines like lightning. Rivets loosened. Bearings overheated. Bolts sheared. The dredge groaned when this happened. You could feel it through your boots, a wrongness, a tension that didn't belong. Experienced operators sensed it immediately. Inexperienced ones didn't. They learned fast or they didn't learn again. Swing engines controlled lateral movement, pulling the dredge side to side using heavy anchor lines run out to fix points ashore or to massive deadweight anchors dropped into the water. These lines were under constant tension. If one parted, it snapped with enough force to cut a man in half. Nobody stood in their path. Nobody sane anyway. Below deck, pumps worked nonstop. Water came aboard constantly through leaks, spray, condensation, and seepage around the spuds. Steam-driven pumps evacuated it in a steady rhythm. If they failed, the hull flooded, slowly at first, then all at once. Flooding didn't always sink a dredge. Sometimes it just made it unstable enough to ruin everything. A list of a few degrees changed the ladder angle, changed bucket loading, changed stresses everywhere. The machine didn't compensate, it punished. Men checked bilges obsessively. Sounding rods dipped into dark spaces. Any rise was reported immediately. There was no ignoring water where it didn't belong. The mathematics of destruction were always running. How much material per bucket? How many buckets per minute? How much torque the engines could deliver before slipping belts or breaking gears? How much tension the chain could take before stretching beyond tolerance? How much pressure the boilers could sustain before the relief valves screamed? Everything was margins. And margins disappeared fast when something unexpected entered the equation. A buried timber. A wrecked ship. A layer of compacted clay harder than expected. A storm surge shifting sediment overnight. The dredge didn't see these things coming. It discovered them violently. When a bucket struck something immovable, the chain jerked. The engine strained. Steam demand spiked. Pressure dropped in one system and rose in another. Operators reacted on instinct, throttling back here, easing there, trying to bleed off stress before iron failed. Sometimes they succeeded. Sometimes they didn't. Breakdowns were not small events. A snapped bucket chain didn't just stop digging. It unleashed hundreds of pounds of steel links whipping under residual tension. Buckets tore loose, smashed into structure, punched through decking. Men scrambled for cover, boots slipping on wet steel. If the chain derailed at the tumbler, it piled up in a tangled mass that took days to clear. Steam was shut down. Boilers cooled. The dredge went silent, an ominous quiet broken only by waves and shouted orders. Repairs were done in place. There was no dry dock, no service bay, just men, tools, and the understanding that the dredge had to work again soon or the entire operation failed. They hammered rivets back in. They cut away bent steel and replaced it. They patched cracks and hoped the metal held. Every repair was a compromise between time and safety. Time usually won. Weather made everything worse. In calm water, the dredge was merely dangerous. In heavy seas, it became unpredictable. Waves lifted the hull, changed spud loads, twisted anchor lines. The ladder surged in and out of the bottom, buckets biting unevenly, engines surging to compensate. Operators tried to match the rhythm of the sea. Sometimes they succeeded. Sometimes a wave lifted the ladder just as a bucket hit resistance, and the resulting shock rippled through the entire structure. That was when bolts popped. That was when chains jumped teeth. That was when men lost balance and went down hard on steel decks slick with spray and oil. Storms didn't stop work unless they absolutely had to. Deadlines mattered. Contracts mattered. The dredge ran until someone decided it couldn't anymore, and those decisions came late. Despite everything, the machine delivered. Tens of thousands of cubic yards removed. Channels cut deeper than any before. Harbors transformed from liabilities into assets. Cities expanded, ports thrived, shipping routes shifted. The dredge did not make headlines. It didn't need to. Its work was measured in altered coastlines, in maps redrawn quietly by surveyors months later. But beneath the progress was an unspoken truth. Every foot of depth came with risk. Every bucket lifted carried the possibility of failure. Every hour of operation stacked pressure upon pressure. And pressure, whether in boilers or men, eventually finds a way out. In Part 3, that pressure finally breaks in accidents, near misses, and moments where entire crews stood seconds away from annihilation, saved only by instinct, luck, or decisions made too fast to remember. Nobody who worked a dredge believed it was passive. They didn't say it out loud, not in a way you could quote, but they treated the machine like something that could turn on you, not out of malice, out of indifference. The same way the sea doesn't hate you when it drowns you, it just keeps moving. Because when a dredge failed, it didn't fail quietly. It failed all at once. The first warning signs were almost always subtle. A vibration that didn't belong. A delay between lever and response. A pressure gauge that climbed just a little faster than it should. Experienced operators noticed these things the way sailors notice a change in wind before a storm. They didn't panic. Panic killed people. They adjusted, throttled down a fraction, lifted the ladder an inch, shifted load from one boiler to another. Sometimes that was enough. Sometimes the dredge ignored them. Bucket chain failures were the most feared, not because they were common, but because when they happened close. The chain was under constant tension, moving thousands of pounds of steel in a continuous loop. Each link was forged thick, but fatigue didn't care how strong you thought you were. Metal stretched, pins wore, cracks formed invisibly beneath grease and rust. When a link finally let go, the sound wasn't a snap. It was a detonation. The released tension hurled buckets outward like artillery. Steel slammed into the ladder frame, shattered guards, ripped railings free. Men dove flat instinctively, pressing themselves against deck plating as fragments flew overhead. If you were standing in the wrong place, too close to the ladder, too near the tumblers, there was no time to move. You were simply struck, broken, crushed, sometimes killed instantly, sometimes not. There were no heroics in those moments. Just chaos, steam venting, engines racing briefly before being shut down, and then silence broken by shouting and the hiss of cooling metal. Cleanup took days. Bodies, if there were any, were removed quickly. Work resumed as soon as it could. The channel still needed dredging. Boilers were worse. A boiler failure didn't target one man. It targeted everyone. Pressure crept up when feedwater lagged behind firing. A distracted fireman, a clogged injector, a moment too long before noticing the sight glass dropping. Any one of these could put the boiler crown sheet above water level, exposing it directly to flame. Steel softened. Rivets loosened. Seams opened. When a boiler let go, the explosion was not cinematic, it was erasing. Superheated water flashed into steam instantly, expanding thousands of times in volume. The blast tore steel plates loose, flung them outward, and filled the interior of the dredge with scalding vapor. Men closest were vaporized or killed instantly. Others were burned so badly that survival was theoretical at best. Woodwork caught fire. Deck plating warped. Steam lines ruptured in secondary explosions. Survivors remembered the sound, not a bang, but a tearing roar that drowned out everything else, followed by screams that cut through the steam. Boiler explosions made newspapers. They couldn't be hidden, but even those didn't stop dredging. They slowed it. Replacement boilers were built, crews reassigned, the work continued. It always did. Then there were collapses. The dredge removed material that had been supporting other material. Banks undermined by careless cuts slumped inward without warning. Entire sections of shoreline slid into the excavation, burying the ladder, jamming buckets, snapping chains. When that happened, the dredge didn't stop immediately. It fought. Engines strained. Steam pressure spiked. The ladder tried to chew through the collapse. Operators pulled back hard on controls, trying to lift free before the weight overwhelmed everything. Sometimes they succeeded. Sometimes the ladder bent. A bent ladder was a death sentence for productivity. Steel trusses twisted out of alignment. Buckets no longer tracked correctly. Repairs meant cutting away massive sections and replacing them in open water, hanging from chains, working over nothing. Men balanced on beams slick with mud and spray, rivet guns in hand, trusting that the dredge would stay still long enough to finish. It didn't always. Weather-driven incidents were quieter, but just as lethal. A sudden squall, a storm surge that lifted the hull and dropped it unevenly. Anchor lines tightened beyond design limits. One parted with a sound like a rifle crack, recoiling across the deck. If it struck you, there was nothing left to bury. Operators learned to read the sky, the water, the wind. They learned when to shut down before things got ugly, but shutdowns were decisions weighed against contracts and deadlines. Management pushed, crews pushed back. Sometimes the dredge went out anyway. That's when mistakes compounded. The men aboard were not reckless. That's important to understand. They were practical. They knew the risks. They accepted them because the alternatives were worse: unemployment, displacement, starvation in some cases. Dredge work paid better than most maritime labor. Danger came with compensation. But money didn't protect you from exhaustion. 12-hour shifts blurred into 16. Night work continued under lantern light. Fatigue dulled reaction times. A missed signal, a delayed throttle, a forgotten valve. Small errors became large problems quickly. There are accounts, half-documented, passed down through oral histories, of near-total losses avoided by seconds. An operator slamming a valve shut just as a pressure gauge pinned. A deckhand diving clear of a recoiling cable at the last possible moment. Luck played a role. Nobody pretended otherwise. What made dredge accidents particularly brutal was isolation. These machines often worked miles from shore, offshore, or in undeveloped harbors. Medical care was distant, communication slow. An injured man might wait hours before reaching help if he could be moved at all. Burns were especially unforgiving. Steam burns didn't look dramatic at first. Skin reddened, blistered, then sloughed away. Infection followed. Pain lingered. Men carried scars for life. Reminders etched into flesh of moments when the dredge came close to killing them and settled for maiming. Some went back to work anyway. And still, the dredge kept reshaping the coast. Channels deepened, landforms shifted, entire waterfronts were reclaimed or erased. What had once been shallow estuaries became deepwater ports. Tidal patterns changed, currents altered. The sea behaved differently now, responding to contours that hadn't existed before. The dredge didn't just move Earth. It rewrote systems. Fishermen complained. Old navigational knowledge became unreliable. New hazards appeared where none had been before. The machine solved one problem and created a dozen more downstream. But from the perspective of industry, it was a triumph. Bigger ships. More cargo. Faster turnaround. The dredge justified itself every day it ran. Yet beneath the success, wear accumulated. Metal fatigued. Crews thinned. Replacement parts lagged. By the time a dredge reached the end of its service life, it was a patched-together monument to compromise. Plates of different eras bolted together, pipes rerouted, engines rebuilt multiple times. Nothing matched. Everything worked barely. And that was when the most dangerous period began. Because a tired machine fails more creatively than a new one. By the time a dredge reached maturity, the point where it had outlived its blueprints, it stopped being an engineered object and became something closer to folklore. No two were the same anymore. On paper, the dredge was still the same 500-ton machine launched years earlier. Same displacement, same rated output, same theoretical tolerances, but paper had nothing to do with reality on deck. Reality was welded seams laid down in bad weather. Replacement parts scavenged from other machines. Steam lines rerouted to avoid cracks that nobody had time to fully repair. It still worked, which made it more dangerous than ever. Because when a machine works despite being wrong, people start trusting it too much. Late-life dredges groaned differently. The vibration profile changed. The pitch of the bucket chain altered slightly, just enough that veterans noticed and newcomers didn't. Steam leaks hissed constantly, patched with clamps and prayers. Gauges stuck, then were replaced with others that read a little optimistically. Crews learned to compensate. They knew which boiler ran hotter, which engine surged under load, which spud sleeve tended to bind. Knowledge passed orally, shift to shift, man to man. There were no manuals for this version of the dredge. The machine that existed now was the sum of every shortcut taken to keep it running. And it had to run. Because by this stage, the dredge wasn't just part of a project. It was the project. Schedules were built around it. Budgets depended on it. Ports planned expansions assuming it would keep cutting at the same rate forever. No one wanted to hear that it was tired. Operating discipline changed subtly. Early on, operators followed conservative margins. As years passed, they pushed closer to limits, not recklessly, but pragmatically. They knew how much more steam they could pull before something complained. They knew how far they could swing before anchor lines protested. They trusted feel over math. That trust saved time. It also eroded safety. Because instinct works until it doesn't. Maintenance became triage. Major overhauls were postponed after this contract, then after the next one, then after the season. Temporary fixes became permanent. Steel plates were doubled instead of replaced. Cracks were stopped drilled and forgotten. Bearings ran hotter than they should, but they ran. The dredge became a floating compromise. And still the earth kept coming up. By now, the machine had reshaped more than coastline. Entire waterfront districts existed because of it. Land reclaimed from the sea carried warehouses, rail spurs, factories. Nobody remembered what the shoreline used to look like, only that it used to be a problem. The dredge worked offshore, invisible to most of the city it enabled. People saw the results, not the process. Deepwater docks, bigger ships, prosperity. They didn't see the men coughing in steam-filled compartments. They didn't see the patched boilers or the worn chains. They didn't hear the subtle wrongness in the sound. Progress rarely listens that closely. Accidents in this phase were different. Not sudden explosions or dramatic failures, those belonged to earlier years. Now, incidents were quieter. A man crushed because a control responded slower than expected. A cable parting because metal fatigue finally caught up. A ladder binding just enough to overload a gearbox that had been rebuilt one too many times. The dredge didn't announce these failures. It simply allowed them. Reports used words like unfortunate, unexpected, operator error. The machine was rarely blamed directly. It had earned too much goodwill for that. Crews knew better. They worked around weaknesses, avoided certain positions, learned which sounds meant trouble. They lived inside the machine's declining health, compensating daily. It took a toll. The mental strain was heavy. Working a dredge always demanded attention, but late in its life, that attention became constant vigilance. Operators didn't relax. Firemen didn't drift. Deckhands watched everything. Because when a tired machine failed, it gave less warning. Men went home exhausted in a deeper way. Not just physically spent, but mentally drained from hours of holding systems together through awareness alone. Some quit. Others stayed because they didn't know anything else. Eventually, the question arose that nobody wanted to ask. How long could it keep going? The answer was always the same. A little longer. At some point, even that stopped being true. Failures clustered. Repairs took longer. Replacement parts were harder to source. Designs were obsolete. Manufacturers no longer existed. The dredge became an orphan of its own success, too important to abandon, too old to easily replace. Engineers debated rebuilding versus replacement. Accountants argued numbers. Managers delayed decisions. Meanwhile, the dredge kept working. Because that's what it had always done. The final years of a great dredge were rarely dramatic. No grand last cut. No ceremonial shutdown. Just diminishing returns. Production slowed. Downtime increased. Crews rotated more often. Younger men were assigned elsewhere. Veterans stayed, partly out of loyalty, partly because they understood the machine in a way no one else did. They knew its moods. They knew its limits. They knew when it was close to being done. And then one day it stopped. Not with an explosion, not with a scream, but with a failure that crossed a line, a crack too long, a frame member too compromised, a boiler too far gone. Someone finally said no. The dredge was shut down. Steam bled off. Fires went cold. The bucket chain stopped mid-rotation, buckets hanging full of earth they would never lift. Silence settled. What happened next depended on money and sentiment. Some dredges were scrapped in place, cut apart where they lay. Others were towed to backwaters and abandoned, hulks rusting quietly as tides worked on them the way they once worked on coastlines. A few were preserved, museum pieces stripped of danger, frozen in time. Visitors marveled at their size, walked decks that once shook violently, read placards that reduced decades of labor and risk to a paragraph. They couldn't feel what it was like. They couldn't hear it. But the coastline remembered. The channels remained. The land stayed put. The ports kept operating. The dredge was gone, but its work endured, reshaped geography that outlived everyone who had ever stood aboard it. And that brings us to the final question. What did it all mean? In Part 5, we step back from the machine itself and look at the aftermath. The world it created, the costs it buried, and the uncomfortable truth about how much of modern civilization rests on the work of machines like this one. Long after the dredge stopped, the land kept pretending it had always been this way. That's the strange thing about Earth once it's been moved at scale. It settles into its new shape with quiet confidence as if no other version ever existed. The channel looks natural. The harbor looks inevitable. The shoreline curves where it curves, and people assume it always did. But it didn't. Before the dredge, ships waited. Before the dredge, cities stalled. Before the dredge, entire regions were limited by water that was too shallow, too unpredictable, too inconvenient for the scale of ambition that was coming. The machine changed that permanently. Once a harbor was deepened, it stayed deep not forever but long enough to justify everything that followed. Bigger ships arrived, shipping schedules tightened, ports expanded outward then upward, warehouses multiplied, rail spurs snaked toward docks, roads followed, neighborhoods formed where water used to move. All of it rested on the assumption that the dredge had solved the problem. And in a sense it had. The coastline didn't revert. The sea adapted. Sediment found new paths. Currents shifted around engineered contours. The world adjusted itself to the violence done to it. Nature always does. But the dredge left more than depth behind. It left dependency. Once a port was built around deep channels, it couldn't afford to lose them. Maintenance dredging became routine. Smaller machines followed, descendants of the original iron monster, lighter, more specialized, still dangerous in quieter ways. The coastline entered a contract it couldn't exit. Human intervention became permanent. There were consequences no one predicted at the time. Altered currents eroded beaches miles away from where digging occurred. Wetlands drained or drowned. Fisheries declined, then shifted, then collapsed in some areas. Harbors that thrived economically found themselves spending fortunes mitigating environmental damage they hadn't understood they were causing. But those conversations came later. When the first 500-ton dredges went to work, the only question was whether they could do it. The fact that they did answered everything else. The men who worked the dredge rarely benefited from the prosperity it created. They were paid for their time, not their impact. When the job ended, they moved on to another dredge, another port, another machine. Some carried injuries. Some carried scars you couldn't see. A few carried stories that sounded exaggerated until you stood on a preserved deck and realized how thin the margin really was. Many never talked about it at all. They understood something that history often forgets. Progress doesn't require witnesses once it's finished. Years later, when cities celebrated their ports, when trade flowed smoothly through channels cut decades earlier, the dredge was absent from the narrative. Its name might appear in an engineering footnote. A photograph might survive in an archive, a dark silhouette against water, steam rising into a pale sky. No one counted the hours spent feeding coal into boilers. No one recorded the sound of buckets tearing into the seabed. No one listed the near misses that didn't become statistics. The machine's violence was absorbed into geography. There is a temptation to romanticize this kind of engineering, to turn it into myth, to paint it as heroic conquest over nature. But the dredge itself didn't think in those terms. It wasn't heroic. It wasn't evil. It was a tool built to satisfy a demand. The demand for speed. The demand for scale. The demand for growth that didn't pause to ask whether reshaping the edge of a continent might have consequences worth considering. That question came later, once the shoreline had already changed. Today we still dredge. The machines are quieter, smarter, wrapped in regulations and monitoring systems. Operators sit behind glass. Sensors watch depths in real time. Failures are less spectacular. But the fundamental act hasn't changed. We still move Earth to suit ourselves. We still redraw boundaries. We still assume the land will accept it. And most of the time it does. Until it doesn't. The 500-ton dredge belongs to a moment in history when ambition outpaced caution and engineering answered with brute force. It was born from necessity and pushed by impatience. It reshaped coastlines not because it wanted to, but because nothing else could. It left behind harbors that built cities. It left behind altered ecosystems. It left behind a reminder etched into geography itself. That the world we live in is not just inherited. It was cut, dragged, lifted, and forced into place by machines that didn't care who stood too close, and by men who stood there anyway. The shoreline you see today is not natural. It's negotiated. And once negotiated, it never truly goes back.